When finding asymptotes, the first thing we need to do is plug the equation into the calculator. This is the way you would plug it in. As we use the calculator, the best way to graph it on the actual paper is by going to the table of values. And you do this by going second graph. When you see the XY values, please put them on your paper and then go ahead and start plotting each point. When you plot the points and you actually draw the line through them, this is what your graph looks like. Now, the main thing here is that X value of 4, which gives you an error for Y. The reason it does that, it's because this is what we call an asymptote, and it is a vertical asymptote because it is a line that goes up and down. It sets the limit of the graph. These are a couple of practice problems, and we're going to do one by one. Let's look at number 1. First of all, we need to see that since there is more than one term on the numerator and denominator, we need to make sure that we use parentheses both on top and the bottom. Make sure you plug it in the way we see it in the graph and the calculator. Then we go to the table. Going to the table, we only transfer the points that they're looking for, where X is 0, 2, 4, and 6. And once again, we notice the error. The error is on 2. So then your vertical asymptote has to be when X is equal to 2. Let's try number 2. Y equals X plus 8 in parentheses divided by X minus 6 in parentheses. Once again, we go to the table, we transfer the points, and we see that when X is 6, that's when we find the error. So this is your vertical asymptote. Number 3, Y equals X plus 1 divided by X plus 3. We do the same thing, go ahead and plug it in, and then we go to the table of values, and we find out that when X is a negative 3, this is when we have the error. This is your vertical asymptote. Number 4, Y equals X divided by 2X minus 12. Second graph takes you to the table, and we find out that when X is 6, this is when you have your vertical asymptote. X plus 7 divided by 2X plus 3. Now this one's a little bit different because of the table. It goes by 0.5. Let me show you how to change that. You would go to second window, which takes you to the table setup. In the table setup, you want to go to the little triangle with the table, and that's what you want each unit to go by. So we're going to put a 0.5. You want the table to start at 0. So go ahead and do that also. Change your table setup to table start 0, each unit by 0.5. Then we go to second table. And it's like the other problems. You could see that the error is at negative 1.5. So your vertical asymptote is at X equals negative 1.5. Next one. X plus 1 equals 0.5x plus 2. Now let's remember to change this. So we go to second window, which takes us to the table setup. And we're going to change the table start to 0 and the table by 1. So now the units will go back to whole numbers. Second graph takes us to the table, and we find out that X equals the negative 4. Now let's try, this is what the graph looks like. So there it is, X equals negative 4. Now we would do number 7. X plus 1 divided by X squared minus 4. Now, We should see that the difference between this problem and the other ones is that the power of x in the denominator is 2. Now let's see what this is going to do to the actual table of values in the graph. When we look at the table of values by going second graph to the table, we see that both -2 and 2 are errors. Now let's take a look at the graph. If we see, we actually have two asymptotes, two lines that are going up, limiting the graph. This would make your vertical asymptote be 2 answers, where x is 2 and x is -2. Now we have a couple of questions at the very end of this whole thing. Are these asymptotes related to the numerator or denominator? As we can see in all the numbers, 1, 2, and 3, it seems like there is a relationship with the denominator. For number 1, we had x minus 2, and the answer is 2. Number 2, we had x minus 6, and the answer was 6. For number 3, we had x plus 3, and the answer was a -3. Now, how can the asymptotes be determined using this part, which is the denominator of the expression? By setting the denominator equal to 0 and solving for the variable. So any time that you're looking for the vertical asymptote, when we do this mathematically, and in case we didn't have a calculator, you would take your denominator, which is the bottom part of the fraction, set it equal to 0, and solving for whatever the variable might be, which in most cases it will be x. Now, this is the reason for this is that when the bottom of a fraction is equal to 0, it's undefined. It can't be happening. So anytime that the bottom is 0, it's going to be your vertical asymptote.